Okay, so with 2.1.1, they were basically asking us to work out the next two terms, given that this is a quadratic sequence. It's a simple question, and for us to work out the next two terms, we firstly want to see what is the second common difference, and then work backwards to us getting our next two terms, right? So all we did was, we know that we wanted to find out the differences between our first four terms, right? Which was negative 31, negative 29, and negative 27. The second common difference was a 2. So all we did was we continued that trend, right? So that we get negative 25 and negative 23. Because all we'll be doing is negative 27 plus 2 gives us negative 25, plus 2 gives us negative 23. So to find these two terms in our sequence, we know it's just 234 minus 25 gives us this value, and then minus 23 gives us 186. So 2.1.2 was asking us to work out the general term of the quadratic sequence that we're dealing with, right? So anytime you need to work out the general term of any quadratic sequence, the very first thing you want to keep in mind is the standard form, right? So in our standard form, we can clearly see that we need three values, right? We need a value for A, we need a value for B, and we also need a value for C. To get A, B, and C, we have three formulas, and those three formulas, we will make use of our second common difference, our first difference, the very first term between term number 2 and term number 1, and then we will use term number 1 in our entire sequence, right? Those three values, 1, 2, and 3, are what we're going to use to get A, B, and C. So exactly what we have done now is what you would want to do, right, to get A, B, and C. For your second difference, you want to equate that to 2A. The first term, right, that you get between term number 2 and term number 1, whatever the difference between these two are, you want to equate that to 3A plus B. And then your very first term, you want to equate that to A, B, and C, right? Working out A, B, and C, you want to start from the very bottom. So we have A equal to 1, right? We're going to take this value for A and sub it into our second equation. So now we have B. We're going to carry on with the process, sub in A there, sub in B there, C will be the only missing variable, and then we're going to equate that to 321 and work out a value for C. Okay, so that's how we get A, B, and C. It's a simple process. All we need to have is our sequence, our first differences, and then our second common difference. Write out these three in front of these first three values, and then work out from the bottom until you have A, B, and C. So as a final answer, this is going to be our general term for this quadratic sequence. This method works for all quadratic sequences, so you don't need to worry about any other way that they will ask this or any other method that you need to use. 2.1.3 was asking which terms in the sequence will have the value 74. So you can clearly see that they're asking for specific terms, right, in the sequence that will have the value 74. What they mean is, in our sequence, in which position, right, will we have 74? This is clearly telling us that in our sequence, 74 is not going to be in one position only, right? It means that somewhere along the lines in our sequence, we have a term that is equal to 74, and then elsewhere within our sequence, we have another term that is equal to 74. This question is asking us for which position 74 will be in our sequence. before we can work out which position 74 is in our sequence, we know that we need to keep in mind our general term, which we just worked out. So because 74 is an actual value in the sequence, we know we have Tn, and then what we need to work out is n. So this is telling us that n is equal to 20 or equal to 14. What that means is, as we said, in the sequence at position number 14, the term there is 74, and at position number 20, the term there is also 74. We can keep in mind that this is a quadratic sequence, right? So clearly we know if we were to plot any of this on a Cartesian plane, it would draw something like a parabola, right? And then with that parabola, we know somewhere along the lines we have 74, and then again we will have 74 in the sequence as well, right? So hence why here we're getting two values and not just one, because this is a quadratic sequence. We can see that the sequence is decreasing, however, somewhere along the lines is going to start increasing again because it's a quadratic sequence. I think I've made my point that with quadratic sequences, you also want to think of how on a Cartesian plane they will draw a parabola, right? With the way we worked out n here I factorized. However, if you don't like factorizing, you can always use the quadratic formula. You will still end up with n is equal to 20 or n is equal to 14.